Hi, my name's Craig. In this video I'm going to go over the NCEA Level 1 Physics, Earth and Space Science exam from 2024. Just question 1 to keep the video relatively short, and then I'll do the other questions as well. Let's get straight into it. So we've got Janet drops a tennis ball from the top of a building. Describe the energy changes or energy transfer that takes place as the ball falls down. Keeping in mind that this falling down is a movement. So the ball falls down, and so if it's falling down, that's a type of kinetic energy. And you've got to think, well, where is this kinetic energy coming from? It must be coming from another type of energy, because energy can't be created or destroyed. So it's coming from that gravitational energy. So gravitational potential energy, which is a type of stored energy, is going to that kinetic energy. That's question A, 1A, which is an achieve tick. The next one is the mass of the tennis ball is 0.0585 kilograms. The tennis ball falls through a height of 14.7 meters. Show that the gravitational potential energy the ball loses as it falls to the ground is 8.6 joules. So in this question, you'll have to refer to the list of formulas you get, and those formulas, at some point you need to be familiar with them, but eventually you should come across a formula that looks like this. So it's delta E, or change in energy. Actually, the one that they show on the exam may actually be, it'll have a P next to it, which is your gravitational potential. Mass times gravity, or acceleration due to gravity, times, I think they do have the delta for the delta H. And so the mass here, they've already given it to us, and this is what you should do in the exam, is to highlight or to circle or underline any numbers that they give to you. So they're already giving us the answer, and we should be working out towards that 8.6 joules. So we've got the mass, and it's already in kilograms. It can't be in grams. They've been really nice to us in this question and just given us the mass straight up. So the mass is this one, 0.0585 kilograms. And they've also given us the delta H, or the change in height, which is a 14.7 meters, and we should end up with this 8.6. So we've got two of the numbers so far. We don't have G, but G is in the list of equations that you'll be getting. 14.7, and it should be 10. So at year 11 level, at year 1 level, it's just a straight 10. Technically, I think it's like 9.8, but we'll keep it nice and simple for you guys. So if you multiply that out, 585 times 10 times 14.7 should give you 8.5995, which is approximately equal to 8.6 joules. And so they just want to see this, that you've done your working. That's 2SF. And they'll go, cool, that's a tick. Cool, calculate the speed at which the ball hits the ground. So in this case here, something that this question, they haven't made it real clear, but you've got to keep in mind the whole context of the question. They may ask parts of questions, they may ask questions that refer to questions before it. Okay, so we're doing question 1, and in this case here, looking at the context, you've got to realize that this gravitational potential energy is going to be turning into kinetic energy, which is EK. So EP, which is what we've just worked out, is turning into EK. We just did a formula at the very top describing the energy change. EP is turning into EK. And so in this case here, EK, and this is really how you should attack physics questions, is you should write down everything that you know. So we know what EK is. We don't know the speed, we're going to calculate the speed. EK is 8.6 joules. We know the mass, okay, because we're going to be, we've got the mass. which is this guy, and we've got the height or the distance that was travelled as well. But knowing these two and not knowing the velocity, that's the question mark, will guide us in terms of what equation we should be using. So we've been given these, and I wouldn't write in the exam given, but I'm just showing you what we're trying to work. This is how you should approach a physics question, especially a calculation one. You get your givens, this is why you highlight stuff in the question. We've got our unknown. And so the equation that you'll find in your list of equations is EK equals, or the kinetic energy equals half mass times velocity squared. Do not forget that squared portion. Now what you can do is you can start chucking numbers in and then rearrange things later on, but I'm going to rearrange it straight up just now. Let's go, maybe I'll go a different colour. Let's go, why not orange? Sure. So if I divide this side and this side by half mass, so that cancels those ones out, and then we go to this one, so EK equals half mass equals velocity squared, and then I'll just, while I'm doing that, we'll do the next step is we'll square root both sides. That's what I'm going to do here, square root, and then also square root this side, so that cancels that. So we end up with velocity equals the square root of kinetic energy over half mass. And if we put the real numbers in there, 8.6 square root, and a half is 0.5, so 0.5 times 0.0585, yeah, 585. We'll come up with the answer as being 17.1 meters per second, 3SF. Cool. And then the last question is the merit excellence question. It says here, in reality, the speed of the ball when it hits the ground is not the same as what was calculated in part above. So pointing out that, explain the reason for this difference, including a statement whether the speed was more or less than what was calculated above. So in this case here, the speed will be less, and that's like an achieve tick. But then pointing out some key things are, things like this is due to the friction with the air as the ball falls. This friction, or you could say air resistance, or you could say drag, okay, but the key things are, you need to point out the friction with the air, definitely. Due to the friction with the air, it slows it down. But you also want to point out where the energy goes, because that's kind of the key thing. We've assumed all the gravitational potential energy goes to the kinetic energy. Okay, we made that assumption, but in reality, what's actually going to happen is we have friction, and friction causes some of the gravitational potential energy to go to heat energy. So this friction causes loss of energy to heat energy. And so you don't have to do this last bit, but I'll show you gravitational potential energy is going to kinetic energy plus heat energy. So that's the actual equation. That's actually what's happening. Yeah, cool. And so making sure you point out key things they want to see in the exam is that you're saying loss of energy due to friction, so friction with the air resistance or drag causes loss of energy to heat energy. Whenever you have friction, you have heat. So you want to point out the heat energy portion of that. Cool.